Hello everyone, I'm Qiao Jing from the University of Pittsburgh and Tsinghua University. Today I'll introduce PubMedQA, a dataset for biomedical research question answering. First, let's take a look at current biomedical QA datasets. They are either too small or not so hard to answer. On the one hand, the largest expert-annotated dataset BioAsk has less than 3,000 training instances. On the other hand, most large biomedical QA datasets are automatically collected without any human annotation, and the questions are extractive and factoid. Our goal is a combination of both worlds. We aim at building a biomedical QA dataset which has many instances as well as some expert annotations and requires complex biomedical reasoning over the context to answer the questions. To this end, we turn to the PubMed dataset. We found that some article titles are actually questions, and abstract serves as a context to answer the title question. So the input of PubMedQA is a title question and the abstract context. Interestingly, we found that about half of such questions can be shortly answered by yes, no, maybe. So we only focus on those yes, no, maybe answerable questions in the dataset. The output of PubMedQA is one of the yes, no, maybe. We also have the long answer, which is the conclusive part of the abstract. Long answers typically indicate and explain the yes, no, maybe answer. They can be used to pseudo-label instances. Now I will introduce the dataset splits and collection. PubMedQA has three splits. The first one is PQA labeled, or PQAL for short. For this, we collected 1K expert labeled instances. 500 of them are used for cross-validation, and 500 of them are used for test. We have the unlabeled split PQAU because long answer can be used to precisely predict the yes, no, maybe labels. We can use PQAU for bootstrapping. We also have the PQA artificial, or PQAA split, motivated by the recent successes of large-scale pre-training. We collect many instances by converting statement titles to questions and automatically assigning their labels. Now I will introduce the dataset characteristics. This figure shows the topic distribution of the PubMed articles, and they are biased towards clinical study-related topics, for example, retrospective studies and treatment outcome. We analyzed the types of questions in the PubMedQA and found that they are typically formatted in the style of clinical studies. For example, does the factor influence the output, and is a therapy good or necessary? In most cases, quantitative reasoning is required to answer the questions. For example, some need to do intergroup comparisons, and others need to interpret group statistics. We present multi-phase fine-tuning of BioBird as the baseline model. We first fine-tune the BioBird on PQAA using the question and context, getting theta 1. Theta represents the parameters of BioBird. Then we fine-tune another BioBird on PQAA and PQAL using the question and long answer, getting theta B2. We use BioBird theta B2 to label the PQAU split. We call this pseudo-label because long answers can directly indicate the yes, no, maybe answers. After it, we fine-tune BioBird theta 1 on the pseudo-labeled PQAU, getting theta 2. Finally, we fine-tune BioBird theta 2 on PQAL using the question and context. In addition, during the fine-tuning, we also introduce an auxiliary task of predicting the long answer back-and-forth statistics. Multi-phase fine-tuning of BioBird achieves 68% accuracy and 52% micro-F, compared to 78% accuracy and 72% micro-F of the single human performance. There is still much room for improvement. In conclusion, we presented PubMedQA, a dataset for biomedical research question answering. Quantitative reasoning over biomedical contents is required to answer the questions, and PubMedQA is publicly available at this URL. There is much room for improvement. Thanks.